Okay, we're going to be discussing section 16.5, which is going to be the second law of thermodynamics. And the second law describes the directionality of natural thermodynamic processes. There are several different ways that you can say this. The engine version of this statement is no cyclic process can convert heat completely into work. If you look at it from a refrigerator point of view, it says no cyclic process can transfer heat from a cold place to a hotter place with no input of mechanical work. So let's take a look at this. This all stems from the fact that we have heat going from hotter objects to colder objects. We don't ever see the reverse. It doesn't happen. So if we look at it again from the point of view of the engine, it is impossible for any heat engine to undergo a cyclic process in which it absorbs heat from a reservoir at a single temperature and converts the heat completely into mechanical work. We just simply cannot do it. There are too many components of changing kinetic energy of a molecule into energy that we can use that has energy being dissipated in heat or in some sort of non-conservative force, that it loses the energy and we cannot take that energy and convert it back into work, or it just simply can't be done. If we look at it from the refrigerator point of view, it is impossible for any process to have as its sole result the transfer of heat from a colder object to a hotter object. In other words, we have to add work to it. So if we look here at figure 16.9, we've got a workless refrigerator here. In other words, if such a thing were to exist, what that would mean is that we could take heat from a colder object and put it in a hotter object, and it wouldn't require any sort of work in order to be able to accomplish that. We don't see that, but if we did have that, this is what it would look like. Now, if we were to combine that with an ordinary heat engine, then we could have something that would be considered to be in perpetual motion. In other words, once we start it up, boom, it just keeps going. That doesn't happen. If we had this workless refrigerator, this situation, when hooked up with a heat engine, would be the same thing as having a heat engine that produces 100% efficiency. In other words, all of the heat is ended up translated into work, and nothing gets dumped into the cold reservoir. So that doesn't happen. We don't see that. If we look at it from a refrigerator point of view, where all of the heat engine's efficiency, where the heat engine is 100% efficient, then we could take all of that work and apply it into a refrigerator. And we could keep that process going indefinitely. And again, we don't see that. That doesn't happen because this is the same thing as meaning that we would have a workless refrigerator, which again, we don't see. We don't ever see heat from a colder object work its way to a hotter object. It's always the other way around. So this conversion of work to heat is called an irreversible process. The engine and refrigerator statements of the second law state that these processes can only be partially reversed. So in other words, take a look at it from this point of view. Gases always seep through an opening spontaneously from a region of high pressure to low pressure. Doesn't work the other way around. And gases left by themselves always tend to mix. They don't unmix. If you allow gases to mix, you don't see them unmix and stay in two separate rooms. It just doesn't happen. Thermodynamically, that's just not how things are going to go. So that's the main point of this particular section. One other description that we can have here, when you take cream and you pour it into coffee, you never see it unmix. It always mixes together. That's the way that two liquids will end up coexisting. And with gases, it's the same way. And that's what is the point of the second law of thermodynamics.